Question 9. The current through an element is shown in this figure. Determine the total charge that passed through the element. The total charge that passed through the element at 3 seconds. Weird phrasing, I think. I think what they're after is determine the total charge that has passed through the element from 0 seconds all the way up to 1 second, all the way up to 3 seconds, all the way up to 5 seconds. Not literally how much charge has passed through at the exact instant of 3 seconds, because of course the answer to that is 0. There can be current moving, there can be charge moving, but at any one particular instant in time, there's no charge moving, because an instant is a very short amount of time. So I think that's what they're talking about, and we know that the current is dq by dt. And if you've seen some of the other problems that we're going through here, then you know that therefore dq is I dt. And when you integrate both sides, you end up saying that the change in charge that has taken place is equal to the integral from some particular initial time to some particular final time, I dt. So all we have to do is say our initial time is 0, and our final time is 1 second, 3 seconds, and 5 seconds. So graphical interpretation of area is just, graphical interpretation of the integral is just the area under the curve. And so all we have to do is, I'm going to make this go up a bit and put it there. All we have to do is say, what is the area from here to here? And the area there, we'll use A for area, don't get it confused with amps, is 1 times 10. And that is 10. And the units, so we got amps for the current and seconds for the time. Nice and easy for us, coulombs. So that's also then the answer. So A is the area, but it happens that it's also the total charge. So we'll say total charge. We used a capital Q on the last question. We'll use a delta Q on this one, just to highlight that. It doesn't really matter what you decide to write. So from 0 to 3 for this one. Well, we have to divide it up a little bit here, because we've got a triangle. So from 1 to 2, we have a little square. And yeah, we've got a little square there. Is there some way that I could write this on the screen? Not really. Let me see. Okay, so figured it out. We got it open in Paint, and then, oh, come on. Oh no, it's not showing. Oh, it doesn't show my cursor on that. But I can draw in here, right? Yes, we can draw in here. Okay, so from 1 to, what was I doing? It's been a while, so I had the recording paused, but it's been a while. Right, so we need to find out the area from 0 to 3. And easiest way to do that is just geometrically. So we want to divide this up into shapes, and we'll recognize that from between 3 and 1, we basically got this rectangle and this triangle. So this triangle here has a base of 1 and a height of 5. So we will say area of the triangle, base of 1, height of 5, divide by 2, and that's equal to 5 over 2, which is also 2.5. And then the rectangle has a length of 2 by 5. So AR will be 2 times 5, which is 10. So then the area between 1 and 3 is 12.5 but the area from 0 to 3 has the 10 as well. So for B, we will say that the total charge from 0 to 3 for B is 22.5 coulombs. And then C wants everything from 0 to 5 seconds. So that introduces a little square here and a triangle. So this triangle is the same area as this triangle. It is 5 by 1. Area of that triangle is 2.5. Just looking at our previous work. The area of that little square, which we'll call a rectangle, is 1 by 5. And that's just going to be 5. So the new area is 7.5. We'll add that to the 22.5. Oh boy. We'll add that to the 22.5. And we'll get, see, if you add the 0.5, then it's 23 and 7, so 30 coulombs. There you go. Piece of cake. After we got the thing in paint working. All right. Yeah.